we're going to cover a couple of things today. First of all, we've learned about several pieces of factoring. We've learned about difference of two squares. We've learned about factoring greatest common factor. We've learned about factoring when we have something other than a 1 in front of the x squared term. We're going to try to put all of that together and then take it a step further and use factoring to solve an equation. So when you go to factor something, you should always check a few things first. The first thing that you should always check is there a greatest common factor? Do the terms have anything in common that we could pull out of all of those terms? Because getting the numbers that you have to factor smaller is going to help you out in the long run. The second thing you should check is this a trinomial? Is it 3 terms, or is it a binomial? Is it 2 terms? If it's 2 terms, it's likely difference of 2 squares. So you're going to be looking for trinomial versus binomial to see if there's any tricks that will help you factor it quicker. And then your third step is going to be to then just factor. So this first one, 5x squared plus 5x minus 10. Do those 3 terms have anything in common? 5. They do not have an x in common because the last term doesn't have an x, but we can divide all of them by 5. So 5x squared divided by 5 is x squared. 5x divided by 5 is x. And negative 10 divided by 5 is negative 2. Now we're looking at a trinomial, so we're going to ignore the 5 for right now. We just know that the 5 will be in front of our final answer. We need to factor this x squared plus x minus 2. And by factoring out that 5 first, this makes it a lot easier for us because now this is a normal, you've got a 1 in front. So we're looking for 2 numbers that multiply to give us negative 2. Those same numbers need to add up to 1. That would be negative 1 times 2. And since the a value is 1, since there's a 1 in front of the x squared, this is just simply x minus 1, x plus 2. And that one is done. Okay, sometimes they use variables other than x, like y or m or who knows what. 8y squared minus 28y minus 60. What do those 3 terms have in common? Can we divide all of them by 8? We cannot do 28 divided by 8. So what's a number smaller than 8 that all of those could probably be divided by? 4. That will give us 2y squared. Negative 28y divided by 4 would be negative 7y. And negative 60 divided by 4 is negative 15. So our answer is going to have a 4 in front. We need to factor this trinomial. We do have an a value. So multiply the 2 times the negative 15. We're looking for 2 numbers that multiply to give us negative 30. Those same numbers need to add up to negative 7. Would that be 10 and 3? 3 and negative 10. And I'm going to do guess and check really quick because I think it'd be faster on this one. I know that the first one's going to be 2y and y because the only way to get 2y squared is to do 2y times y. Then 2y times something, probably not going to give me the 3, it's probably going to give me the negative 10. So that needs to be a negative 5. And then the y times something, that'll give me the 3, so there's the 3. So my final answer is 4 times the quantity 2y plus 3 times the quantity y minus 5. It bothers me that that's big like that. There we go. Okay, the other thing that we really have to do even before we check for greatest common factor is make sure that we have this in standard form. Standard form means your x squared term is first, then your x term, then your number. So this first example, is this in standard form? We got the m squared, then the m, then the number. Now we've got an equals 0. You want it to be equals 0. So equals 0 is important. You want this problem to be equal to 0. Ignore the equals 0 for right now. Let's just factor the left. So 9m squared minus 30m plus 25. Do those three terms have anything in common? Not 5. They don't, do they? No, that's unfortunate. So we need to multiply the 9 times the 25. Whew, 225. And those two numbers need to add up to negative 30. I am definitely going to use my calculator to help me on this one, if my calculator wants to load. 225, I know we can't do divided by 2 because it's odd, so I'll try 3. 3 and nope. 225 divided by 4, doubt it, that's a decimal. 225 divided by 5. 5 and 45, that would not get me 30. 225 divided by, I don't think 6 is going to work. Nope. 7, 8. I don't think 9's good. Oh. Would 9 and 25 get me 30? Can anyone see what it's probably going to be? It's not going to be 10. 225 is the perfect square of 15. 15 and 15 would give us negative 30. So negative 15 and negative 15. And would I be lying if I said that finding the pair of numbers is always super easy? Yeah, I absolutely would be lying. Sometimes finding that pair of numbers can be frustrating, but just keep going. You'll find it eventually. Okay, I'm going to do guess and check. And I said to another class, it's not really truly guess and check. It's kind of like educated guess and check. So I'm going to do 3m and 3m. I'm choosing to do 3m because both of these numbers are 15. So I'm not going to get 15 from 9 times something. I'm probably going to get 15 by doing 3 times something. So 3m times what is negative 15? Negative 5. 3m, that one also has to be negative 5. So our final factored form is 3m minus 5 times 3m minus 5 equals 0. Okay, we're going to pause for a second and play a little guessing game. I'm going to say that behind this green card, there is a number. And behind this purple card, there is a number. And if I multiply these two cards together, I'm going to get 0 as an answer. Guess the numbers behind the purple or green card. If 0 is the answer, what number has to be under at least one of those cards?
0.
A 0. So the green card has to be 0, or the purple card has to be 0. That's basically what we have here. This first set of parentheses is the green card. The second set of parentheses is the purple card. So either the green card equals 0 or the purple card equals 0. So you set this up as two equations. Either 3m minus 5 equals 0 or, well, shoot, they're the same. 3m minus 5 equals 0. So there's really only one solution here. Add 5 to both sides. And then divide by 3. Our solution is m equals 5/3. We just solved the equation using factoring. Now I'm probably going to give you way more information than you really want at this point, but oh well, that's what's fun, right? If I were to graph 9x squared minus 30x plus 25 equals y, it would be a parabola that would touch the x-axis at 5/3. When we are solving a quadratic equation by factoring, what we're really doing is we're finding the x-intercepts. We're finding the place where this parabola is going to touch the x-axis. So that's kind of how, that's why we're doing factoring now, because we started with parabolas and now this is another part of parabolas. Okay, number 4. First step, is it in standard form? It looks like it's in standard form. It's x squared first, then x. It equals 0. Do these two terms have anything in common? 2x. 2x squared divided by 2x is x. And then here's the tricky one. What is 2x divided by 2x? 1. You have to write that 1 in there. Because remember, if we wanted to do the distributive property to get back to what we started with, you have to have something to multiply that 2x by in order to get that term of 2x. Okay, this one, it's done. There's no more factoring that we can do. And this one's a little bit weird because it doesn't have 2 sets of parentheses. So this time, the purple card is the 2x, and the green card is the x plus 1. So if the purple card equals 0, 2x has to equal 0. If the green card equals 0, x plus 1 has to equal 0. 2x equals 0. How do you get rid of the 2 in front of the x? Divide by 2, and 0 divided by 2 is 0. The other one, you'd subtract 1 on both sides and get x equals -1. Now, you guys might be annoyed by me, but I'm going to do this anyway. If I graph 2x squared plus 2x. Nope, that's not what I wanted. There we go. Notice it crosses the x-axis at -1 and at 0. So we just found the x-intercepts for the parabola that we originally started with. So these are our solutions. All right, number 5. What's wrong with number 5? Is it equal 0? No. So first thing we need to do is get this to be equals 0. So I'm going to subtract 4p squared on both sides. And I'm going to subtract 24 on both sides. So I want this side over here to equal 0. Okay. Do these two terms have anything in common? No. Is this a trinomial or a binomial? This is a binomial. It's only 2 terms. And do you see anything interesting about this, this number right here? It's 7 squared. So this factors into p plus 7, p minus 7 equals 0. All right, the purple card is p plus 7. So p plus 7 has to equal 0, or the green card, p minus 7 has to equal 0. Solve both of those equations. What number plus 7 is 0? -7. What number minus 7 is 0? +7. Our 2 solutions are 7 and -7. If it's just p or x or whatever letter and then plus or minus a number, do you see how the solution is the opposite of what's in the parentheses? That's kind of a shortcut there. Try number 6 on your own. Pause the video. First, we get one side equal to 0. You really want this squared term to be positive. So when you're figuring out which side to get to be equal 0, keep your squared term positive. Once we get 0 on one side, this is a fairly easy factoring problem. We got 1 and -8. Put those in the parentheses. If the yellow set of parentheses has to equal 0, -1 plus 1 would give us 0. So the answer is -1. If y minus 8 has to equal 0, then y has to be 8 because 8 minus 8 would be 0. So 8 is our other solution.